Hess law of constant heat summation. The law states that overall the enthalpy change for a reaction is equal to sum of enthalpy changes of individual steps in the reaction. To determine the overall equation of reaction, reactants and products in the individual steps are added or subtracted like algebraic entities. Also, to obtain the overall enthalpy change for the reaction, the enthalpies of the individual steps are added or subtracted. Consider the synthesis of ammonia. The synthesis of ammonia takes place into two steps. In the first step, 2 moles of hydrogen gas reacts with 1 mole of nitrogen gas and they produces 1 mole of N2H4 gas. The enthalpy change for the step first is delta R H naught 1 is equal to plus 95.4 kilojoule. In the second step, 1 mole of N2H4 gas reacts with 1 mole of H2 gas and they produces 2 moles of ammonia gas. In the second step, enthalpy change is delta R H naught 2 is equal to minus 187.6 kilojoule. To obtain overall reaction and the overall enthalpy change for the reaction, the step first must be added in the step second. In both the steps, the similar entities or the substances in both sides we cancel together and remaining right for overall reaction. Also, we add the enthalpies of individual step first and individual step second. The enthalpy of the second step is minus 87.6 and enthalpy of the first step is 95.4. Then these are must be added. So 6 minus 4 is equal to 2, 7 minus 5 is 2 and 18 minus 9 is 9 and the sign of the larger number is minus. So overall enthalpy of the reaction is minus 92.2. This obtained by adding the individual step 1 into the individual step 2. The overall reaction is 3H2 gas plus 1 N2 gas. They produces 2 moles of NH3 gas and the overall enthalpy of the reaction is delta R H naught is equal to minus 92.2 kilojoules. This obtained by adding the enthalpy of the first step, which is delta R H naught 1 plus enthalpy of second step, which is delta R H naught 2. The sum of the enthalpy changes for steps 1 and step second is equal to the enthalpy change for the overall reaction. Applications of Hess law. The Hess law has been useful to calculate the enthalpy changes for the reactions with their enthalpies being not known experimentally. For example, to calculate the standard enthalpy of the reaction is 2 moles of iron reacts with 3 by 2 moles of oxygen and they produces 1 mole of Fe twice O thrice. This is the oxidation of iron, also we called the rusting or the corrosion of iron. This reaction it is very slow. That's why experimentally to calculate the enthalpies of this reaction it is not possible or easy. To obtain the enthalpy of such reaction, we use the enthalpies of the known reaction. For given the reaction first, 2 moles of aluminium reacts with 1 mole of Fe twice O thrice. They produces 2 moles of Fe plus 1 mole of Al twice O thrice and the enthalpy, standard enthalpy of the reaction is minus 847.6 kilojoule and the second reaction is 2 moles of aluminium reacts with 3 by 2 moles of oxygen and they produces 1 mole of Al twice O thrice and the standard enthalpy of this reaction is minus 1670 kilojoules. Look at in the desired equation. Fe twice O thrice present in the product side, but this present in the reaction first in the reactant side. To obtain this Fe twice O thrice in the product side, the equation first must be reversed. If the equation first reverse, so standard enthalpy of the reaction is minus 847.6, changes their sign to plus 847.6 kilojoule. Also, one point is noted that in this desired equation there is no presence of any aluminium or Al twice O thrice. When the equation first and equation second adding, at that time both aluminiums in both the reactions, also Al twice O thrice, are cancelled together. So the equation first reverse and then add into the equation number 2. So we get 2 moles of Fe plus 1 mole of Al twice O thrice and 2 moles of aluminium plus Fe twice O thrice, and the standard enthalpy of this reaction is plus 847.6 kilojoules. This changes from minus to plus because the equation first reverse and the equation second add into this equation first. So we get the overall reaction. To obtain overall reaction, the similar substances from both the equations must be cancelled together. Here Al twice O thrice in this equation are cancelled from the equation number 1. Also twice Al is cancelled from equation number 1, and the resulting overall equation is twice Fe solid plus 3 by 2 O2. It gives to Fe twice O thrice, and the standard enthalpy of overall reaction is obtained from the summation of the two enthalpies. Enthalpy of the second equation is minus 1670 kilojoules plus standard enthalpy of the first equation is plus 847.6. These are subtracted, so we obtain 0 minus 6. अब यहाँ पर 0 में से 6 माइनस नहीं हो रहा है तो हम यहाँ से 1 लेंगे, लेकिन यहाँ पर भी 0 है तो हम यहाँ से 1 लेंगे तो हमें क्या मिलेगा, यहाँ पर 10. सो 10 में से एक यहाँ पर हमने लिया तो हमें मिलेगा यहाँ पर 10 और यहाँ पर बचेगा सिर्फ 9. सो 10 माइनस 6 वी गेट 4. अब यहाँ पर 9 माइनस 7 सो वी गेट 2. So 6 minus 4 we get 2, and 16 minus 8 we get 8, and the sign of the bigger number is minus. So the overall enthalpy of the equation is minus 822.4 kilojoules. The overall enthalpy of the reaction is delta R H naught is equal to minus 822.4 kilojoules. This enthalpy is easily calculated from the known enthalpies of the known reaction.
For newer and newer videos, please like and subscribe my channel and press bell icon button for updated videos.